Okay, let's go.
Hi everyone, this is Anjali. I am a software engineer in Big Tech, and this is my series where I would take you through an interview coding question in hopefully every video. So, yeah, if that's your jam, give me a like, follow me, and let's start. Today's interview question is the famous two sum problem. So, let's dive in. Hey guys, so let's go through the two sum problem. For any problem, even if it's something that I've read 100 times before, in the interview I like to read it again and make note of the things that I feel are important and are going to help me. So let's do that. So given an array of integer nums and an integer target, return indices of the two numbers such that they add up to the target. So this is mostly the template that I follow. So the input is an array of integers. So in this case, 2, 7, 11, 15. And there's also a target value, in this case 9. Output is this is why writing down is so important, because the output is an array of two indices. Normally for a problem like this, I've seen a lot of similar problems where the output is just like a false, or just return the numbers itself, right? A false or true, or return the numbers itself. But this one clearly says it's the array of two indices. So that immediately tells me that when I am doing the problem, I need to have a way to keep track of the indices itself and not just the value. The other thing that has saved me a lot of times is actually making a note of the constraints. So are there any constraints here in this problem? Yeah, there is. You may assume that each input would have exactly one solution. So exactly one solution, and cannot use same element twice. This is important because it tells us that as soon as we find that one solution, we can break, we can return, and our program can end. This is exactly why this is an easy problem on LeetCode and not a medium, because if this constraint was not there, the immediate question that would pop in your mind is what do you have to do if there are multiple solutions, right? So in that case, that is something you would want to clear with the interviewer. We don't have to worry about that here, so we can start. So in this case, we definitely, the output is an array of indices, so we need a results array. So, and we also know that it is an array of length 2, so it's not a dynamic array, so that's good. So yeah, let's start. Oh no, so now before we start, right, let's actually think through our algo. For any problem, it's great to start with the brute force. Tell your interviewer that you know the brute force solution, just quickly explain it. But and that's always good. Like interviewers like to hear your thought process, right, and like to see how you got to the most optimal solution that you could. So in this case, brute force would be pretty straightforward, right? Like you iterate through every single element. When you iterate through the first element, you go through the rest, and you see that, okay, you saw 2, is there a 7? Yes, there is. So 2 plus 7 equals to 9, so return 2 and 7, right? But in that, obviously the worst case is that you might go through the whole array before you find the solution, and in this case you'll go through it multiple times, right? So it would be a big of n square time complexity in the worst case, which is not likely. So let's see if a not good. So let's see if we can find a better time complexity, big O of n. So in this case, I like to think about how did my brain get to the solution it did, right? So in this case, clearly, as soon as I see the array, I see the target 9, I immediately can see that, okay, 2 and 7 is is the answer, right? That's the answer. And how did I get it? That's because internally my brain went through this array left to right. It saw a 2, so it registered that I saw a 2, then I saw a 7. So my brain registered that, okay, I saw a 7, what I need is a 2, and wait, I did see a 2 before, right? So that's how my brain registered that this is the answer. So in this case, at least, that is exactly what we can do. So we all we need is a way to store numbers that we have seen, so that when we see a number, all we have to check is that if the remainder, in this case when we saw 7, all we have to check is the remainder 2, have we already seen it? So And if we do that, we don't need to go through this array n square, right? We can just go through it once, as long as we keep track of every number that we have seen before. And this is where writing the output helps, because now that I know that it's not just a number, but I want the indices that needs to be returned. So that tells me that in addition to keeping track of the number itself, I also need to keep track of the indices, which means that I need a map. And I don't need an array, I need a map, right? So let's do that. So it would be a map of integer key and integer value, where the key would be the number that I found, that I encountered, and the value would be the index at which I saw that number. So now that we have the algo, it would be big O of n. Looks like it would work. Let's go through it, right? So let's start iterating through the array. So like I mentioned, in every case, we want to know what the current number is, current number at that index. So in current equals to nums of I. What is the diff that we are looking for, right? So it would be target minus current. So it would be target minus current. So this diff actually becomes the key that we need to look for in our map to see if the diff was actually seen before. So in this case, if lookups dot contains key diff, which it would not, right? Initially, when we go through 2, the diff is 7. There is no 7 that we saw. So in which case the 7 doesn't exist. So it would go into the else loop, where I would just need to put this into the map. Lookups dot put the current value, comma I, right? Then we would go to the second one, which is 7. Current is 7, diff is 2. Does lookups contain 2? Yes, it does. So in which case we know that we have found our result, and that we can now return it. So results of 0 equals to I, or actually lookups dot get diff results of 1 equals to I. And like I mentioned, considering there is only a single solution, we can just return results, right? Else, so see, now because we are returning results, we don't even need an else. We know that there would not be an else. So if this program goes inside this once, that's it, we are done, our program is over. So this can just be after this. So lookups dot put current I, and in this case it can just return null, because we know that if we don't get this, we don't want to return anything. And in any case, this clearly says that it's exactly one solution, so this case will not really even happen, right? So let's run this and let's see. Oh, okay, there's a typo here. This needs to be out. Okay, now I think it should work. Great. Yeah, so it works, and yeah, this is pretty much it. This is what this is the most optimal way to solve to sum. The time complexity here would obviously be big O of n, but so would be the storage complexity. So yeah, so guys, if you like that and if it was helpful to you, please follow, and I'll see you in the next video. Bye.
Okay, let's go.